Hello, today I will be giving you a demonstration of the Aurora scheduling tool. This is intended to give you an introduction to Aurora and some of its capabilities. It won't be a deep dive into Aurora's functionality, so please feel free to follow up if you have any questions or would like a more extensive demonstration. First, I'm going to give you a little overview of the way the model data is set up, and then we're going to do some scheduling and tweak the data to reflect a real-world change scenario. So first, what goes into the schedule? Well, over here I have my project. In this case, it's just one project, but we can do many, many projects. That is primarily a question of how you organize your data and whether you are building one thing or many things in this model. Each of these is a specific activity or operation or job. Basically, it's a unit of work. And normally, I might see either the unique identifiers for your domain or the name of a job. Because this is a real-world data file that has been changed to be more generic to protect the innocent, it's just showing numbers. But that is a feature of the data, not a feature of Aurora. In this middle area, I can see the details for a given job. What properties are available is configured for a given domain. The subset of properties that actually influence scheduling is usually a small subset of these. And to show you that, I'm going to switch to the tabular editor, which is our configurable Excel-compatible view into the data. You can think of it as a combination of an ad hoc reporting system and data entry system. I can look at any of my key types, view the data, edit the data, change what data I'm looking at. Here I'm showing you some of the most common kind of key information I need for scheduling. So how long does my job take? All else being equal, there are ways that I can tweak that. What labor resource requirements does it need? What zone resource requirements does it need? Now, zone requirements may not be there for your domain. These tend to be very important for aerospace assembly type things because there is actual space involved in putting things together. For example, you can only fit so many people in the cockpit, so it's really important to model that. But not all domains have zone requirements. Usually a domain will either have labor requirements and zone requirements and possibly equipment requirements, or they will have labor requirements and equipment requirements, depending on what drives their specific schedule. And then finally, I have constraints. So in this case, this particular job has one predecessor, so I can see that visually here. This sort of bluish link is the actual predecessor. The grayish link in this view is actually a schedule output. That is a resource contention. So basically this is showing me that this job first was waiting on 28 to complete, and then it had to wait a little bit more for 227 to complete because of a resource contention. And I can drill in and get more details on that. I'll show you that a little bit later. So this covers a lot of the key information for my model. This is the PERT chart. This is how you would normally see the structure of your data. How useful it is depends enormously on the structure of your data and how big your model is. If it's a 10,000 activity model, the PERT chart tends not to be very useful unless you're working with a subset of the data. But for a model this size, it's actually quite nice to see the flow of work, especially because the work has been colored based on work category so that I can really see the way things move through the build. I will note that all of that appearance information is information that the user can set and change. So this was actually built manually specifically for this model. What tends to happen is for a given model, the users will build a handful of appearance configurations, coloration schemes, and so on that work well for that model. That data will save with that model, and they can also save it for reuse or for sharing with colleagues. So the visualization is really important for sharing information about the model and understanding the model. I'm just going to come back and show you a few more of my key types. So for resources, I have different types of resources. Again, this kind of corresponds with the types of resource requirements I have. So I might have labor, I might have zone, I might have equipment that may have some additional restrictions, and then there may be some additional domain-specific types of resources that may or may not have additional logic associated with them. Now, to use resources, if it is a unique resource or I know exactly what I need, I would call out a specific resource. So for example, usually with the space type resources, they are unique. It is where the work is happening, and so the resource requirement on the job or activity would refer specifically to that resource. However, in many cases, including labor and often equipment, I may have some flexibility. So the purpose behind resource sets is to define what resources are interchangeable in a specific context. So down here you can see that I have my different labor resources organized into teams. These teams for this particular model are considered to be interchangeable for a given piece of work. So if I need one of this particular team, any one of these people could do the work, and that would be considered okay. Now, most domains do have some sort of labor resource sets, whether it's based on certifications or whether it's kind of built manually based on experience level and type of labor. All of that varies, but usually you do have some flexibility in who is doing the work. Similarly, if you're scheduling a model where there is equipment required, very often that equipment will also be in sets. I will note that not all equipment usually gets modeled in the schedule. Obviously, if I am assembling an airplane, there is quite a lot of equipment required, but most of that equipment they have enough of that it does not constrain the schedule. So usually I would only include resources in my schedule if it is either going to constrain the schedule, in which case I definitely want to model it, or if I just want to keep track of it and keep an eye on it because maybe I'm concerned that it may eventually start constraining the schedule, or if it's something like extremely expensive drills or other equipment where I can get more, I just need to keep an eye on how many I'm using so that if I need to get more, I can. So in that case, I would model that in the schedule, but I might make it tracking, which would mean it would not constrain my schedule. It would not make my schedule longer. I would assume that I have as much as I need, but then I can see how much I need. Okay, in this particular model, I'm not using job types. That's sort of for reusable jobs that come up a lot, so I don't want to have to redefine them. This is only used if the data is being managed manually in Aurora. Most often, model data is coming in from another system. And then, of course, I have my work calendars. So in this particular model, I'm working a 2-shift, 5-day schedule. We can manage most of the work calendars just out of the box. The user can make them and define multiple work shifts and multiple work schedules, and those will interact in an appropriate way. Most of the time, the calendars are applied to the labor resources, as you see here, because again, it's reflecting who can do what work when. In some cases, it may also be applied to the specific jobs or activities. For example, perhaps a job is very noisy, and so it needs to follow the kind of noise restriction, so be between maybe 7 a.m. and 9 p.m. or something along those lines. So there's a lot of flexibility in terms of how you apply the calendars. In terms of the actual scheduling, we take the intersection, so it combines the different calendar restrictions and will then find the acceptable window that honors all of those constraints. Okay, so at this point I've gone over the key types that go into the schedule, so I am going to schedule. This is a small model, so it schedules very quickly. This pop-up, there are logic checks that run before it schedules. Some of them are correctness checks, things like checking for loops in your model. Some of them are domain-specific model nicety checks. So in this case, it's complaining because I have a bunch of jobs or activities that are 0 durations, but they are not marked as milestones. So for this particular configuration, they want this shown to basically encourage the industrial engineer or other user to go and clean up their data a little bit, but it does not prevent them from scheduling. Now, what the scheduling does is basically it goes through, lays in all of the jobs or activities automatically, and what that means is it figures out timing that will honor any precedence information, the duration information, any other timing restrictions from calendars or shift relationships, and the resources are available. So it is doing resource-loaded scheduling by default. Okay, so let's look at a few schedule results. So you can see that I have some existing plots set up. I will note that the plots are very configurable, so I can make more for various purposes. Usually what tends to happen is that there are a few plots that always exist in a model because they show standard views into what is important in that model. And then I might do ad hoc displays to cover certain specific situations. So I can make more displays. This was built up manually for this particular model, and the color is set using these conditional appearances. So all of this is something that an experienced user can set up and manipulate without any programming being involved. Okay, so with that preamble out of the way, what am I looking at? So in this case, I am looking at my labor schedule. So these are my various labor resources. You can see that with the way the teams are chunked up relative to the major tasks, which is the driver for the coloration here, we tend to have a team working at one major task on a kind of consistent basis until they switch to another one, with some exceptions. So for example, this team does more kind of floater work. The degree of consistency varies. Now, with labor schedules, what makes a labor schedule good varies quite a bit. In this particular domain, our priority is getting the work done as quickly as possible. So it may be possible to have the labor be somewhat more coherent and use fewer people or things along those lines, have it be more reproducible. But here we're just trying to get all of the work done as quickly as may be. And so that is why you see the gaps and things. The other thing worth noting is here I am just building one unit. And with a model like this, usually there are a whole bunch of units going on, interacting in sequence. So usually, for example, this labor group would do the green work for this unit, And then they'd probably go and do the same green work for another unit in this gap before coming back to the teal work. Now, you can model all of that in Aurora in what we would call a multi-ship or multi-unit model. You can take the single unit models and import them into a larger model so that you can actually see the interactions working dynamically. But today, just to make it easier to understand what's going on, I'm showing you a single ship model. So that is part of the reason for these gaps. It is not reflecting everything that is going on in the universe. Okay, now other things, zones. So this is what I mentioned with things like cockpits. Note that one thing with zones that is different from some other situations, such as large equipment, is zones are only usually in use when the job is active. Now, there are configurations you can tweak if that isn't true, but for example, in this case, you can see that partly I'm splitting over the weekend, but I'm also driven by what shift this labor is working. You can see that here, I actually had a few other jobs come in and get worked on shift 1, while the pink work was kind of paused because the labor was not available. So that is a characteristic of zones or some other resources. It basically is a question of whether a resource should be held and locked down when work is not going on, or whether it gets freed and other things can kind of sneak in and occur in between. So in this case, we have allowed other work to come sneak in between, because when work is not active, that zone is not in use. So there's a lot of flexibility to configure the way your resources are used through time to allow you to model accurately. And that, again, is partly because you can define your different resource requirements and you can define your different resources and have those interact appropriately. Now, one thing I will just mention, because some other scheduling systems do model this differently, by default, you call out exactly what you need. We do not presuppose any relationships between different resource types. So in this particular case, I actually have a couple different labor resources required here. The space zones required do not necessarily reflect that. So this is one labor, this is a second labor. My zones do not call out 2. That's because I just need to lock down the zone. I don't, in this particular case, the fact that there are 2 people versus 1 person does not change the amount of space I need to lock down. So you can see that they actually did not need as much of this space. So there are pros and cons to this. This gives you a huge amount of flexibility, but it does mean that you actually have to think about how those relate. We don't just presuppose that 2 people take up 2 spaces. Okay, and now I'm going to come to my Gantt chart. So the Gantt chart is a standard cascade. This one is configured to be a summary Gantt chart. So that's the reason I have a fewer number of colorful bars. The default Gantt chart, of course, is a big cascade. So here is my default Gantt chart, which has not been customized at all. So you can see that that shows me my big cascade of work, but honestly, that stops being useful once I'm above maybe 100 jobs at most. So it's very common for people to put together a summary Gantt chart that will give them a high-level view of what's going on. This one has been configured so that if I want to drill down, I can click on a summary bar, and in this case, the relevant jobs show at the bottom. And all of that, again, can be configured by the user just based on the graphical settings. Okay, so that is it for the basic schedule results. Now I'm going to show you a couple different things. So first I'm going to show you a what-if scenario. What happens if I have a major parts delay? This is unfortunately very common in a real-world scenario. And then I'm going to show you a little bit more of how you can better understand your schedule. One thing that is really important with scheduling is giving the user some transparency about why the schedule is the way it is, so that they can both be comfortable that the schedule is doing the correct thing, but they also have the potential to refine their model to give a better schedule. So I will be coming back to that in a minute, but first we are going to have a vicious delay. So you can see just by looking at the model structure, kind of the units of work and where work gets kicked off. So I'm going to say that activity 104 is going to have a parts requirement. So you can see that this is a removal, but it is also the start of a set of work. So maybe I'm removing something so that then I can install something else and then put things back. So I am going to say that there is going to be a 1 week delay on this. So I'm just copying the original start date for when it was scheduled to occur. So this wasn't a restricted date, it's just where the scheduling system put it. And I'm going to change the earliest it can begin to be a week later. So this is a confirmed week-long delay of this particular job and the jobs associated with it. And we're going to see what that does. So I'm going to go ahead and schedule again. Okay, so to show you the results, I'm going to look at the summary Gantt chart initially, and I'm going to compare with the previous version of the model. So this is a snapshot that I took before beginning the demonstration. It basically records all of the date information and all of the resource assignments so that I can run this sort of comparison. Okay, so the way the summary comparison works is this sort of grayish rectangles show the previous version of the schedule, and the more intensely colored rectangles show the current version of the schedule. So from this, you can see that out of the 1 week delay, I basically lost just shy of 2 days. So I previously finished here on Monday, and now I'm finishing a little earlier in the day on Wednesday, but considering that I lost 5 full work days, that's not too bad. Now, in terms of what changed, because of the way this model is segmented, you can see that actually most of the subtasks were not impacted. And that's because in this particular model, those work streams are relatively independent until I get to the end of the build process. So what did change? Well, if I click on this particular subset of work, so you can see that this is actually some of the work that I delayed. So it used to be back here, now it's over here. So logically, that means that this work that I am starting with actually moved much earlier. So basically, in this subset of work, just looking at the PERT, you can see that I have 2 relatively independent chunks of work associated with this subtask. So it basically flip-flopped them. Doing this delay meant that this couldn't start, so it started that instead. The goal here is to make sure that we are continuing to have as good a schedule as possible without disrupting things unnecessarily. the degree to which it makes sense to keep your schedule dynamic depends a little bit on time horizon and whether things are in work already, and how nimble your particular factory area is. When you're in the planning stage and no work has started, you want everything to be as fluid as possible, but if you're in execution, you may want it to be a little less fluid, actually. Okay, so at this point, I'm going to kind of circle back and talk a little bit about understanding your schedule results. I won't go super in depth, but I do want to kind of show you the way the different pieces interact. So I'm actually going to come back to jobs, and you may recall that my very first job, when I looked at its little single element context display, had that gray link indicating that there was a resource contention going on. So I'm going to use that as an example. So if I look at the schedule results, this explanation is constructed automatically as part of scheduling, and its goal is to give the user visibility into why the schedule is the way it is. There are some higher level analytics allowing you to find, for example, the causal chain for a given activity, what is the driving sequence for that activity. But this here is basically telling me for this particular thing, what are all of the ingredients that went in? So basically, first, did I have a restricting start date? Then, did my project have any restricting dates? And yes, my project was starting January 2nd, 2025, and so it scooched everything over to that. For this particular project, I have a limit to how long I want the build to take, so it put another restriction based on that. It bumped it over a little bit based on when I was actually working, so that is a reflection of my work calendar. Then it bumped over some more based on precedence. Now you can see that the same predecessor is shown twice. The reason for that is the first time is preliminary propagation before I've actually laid anything in the schedule. So this is basically reflecting my pure temporal schedule if I didn't have any resource contentions. And then this one is after the predecessor, job 28, had scheduled. This bumps it over further. So this is basically saying if I had no resources, logically the earliest it could occur is January 9th. But based on resource contention with both the predecessor and anything upstream, the earliest it can occur is January 15th. And this is useful information both for understanding why the job scheduled where it did, but also kind of getting a sense for opportunities of whether it could have been earlier. You know, if this shows January 9th and this shows January 10th, that means that resources are having very little impact on where this schedule's kind of upstream in the network. And so if I were trying to move it to the left, adding resources isn't going to help very much. In this case, because it actually was delayed by almost 6 days, if I did want to move this to the left, there is some pretty good opportunity to do that by adding resources. And then the last thing, and this won't show up on all of the jobs, but if a job was waiting for a resource to become available, that will be listed. So in this particular case, I was waiting on a labor resource, but it will show something very similar if I had been waiting for a space zone or waiting for equipment or anything like that. Okay, so I'm trying not to get too in-depth here, but I just want to take a step back and talk a little bit about Aurora and the philosophy and some of the unique things we have available under the hood. So the thing about scheduling is there is no such thing as a good generic scheduling system. That's because each area has its own concerns and requirements and unusual things. And what makes a schedule good depends on the priorities of a given area. So, for example, would you rather have the shortest possible schedule, or would you like consistent work where someone is kind of working along a standardized sequence within the PERT? There can be advantages to either one, but that is domain specific. So our philosophy in Aurora is to make it easy for us to customize. So usually for a new client, we would plan to customize some of the logic, and then in addition, to give the end users a good range of properties so that they can influence the schedule without further customization. So I'm not going to go into these in detail, but we have settings that influence how an activity interacts with the shift structure, whether it can occur at the same time as other jobs, whether there are times that things can schedule at the same time when maybe they couldn't usually, all sorts of things along those lines. Similarly, with the resources, we have a lot of settings determining how they should behave. So the goal is to have a customized scheduling system that has been tailored for a given domain, but also allow the user a lot of access and control to fine-tune their model to get different behaviors and more accurately model what's going on in their specific factory area. Because even for a given domain, it is very common to need somewhat different behaviors within different areas. We have the same philosophy with, for example, the displays and configuration. Very often we'll make certain common things easier as part of the domain customization, but the users can always add more displays, tailor those displays, tailor the visualizations, because we understand how important that is for sharing information with other groups, and that can be very key for improving the model and therefore improving the schedule. Okay, so this is it for the Aurora overview. There is a lot I have not covered, so again, feel free to follow up with any questions or a request for a targeted demo. But I hope that this has given you a little bit of the flavor of what Aurora can accomplish for you. Thank you so much.